All right, so we have 4 exponent is 50, okay? Now we can write 50 as 10 times 5, okay? So our equation becomes 4 exponent is equals 5 times 10. All right, now we can write 10 as 5 times 2. So our equation becomes 4 exponent x equals 5 times 5 times 2. Okay, all right. Our equation becomes 4 exponent x equals, now 5 is the same as 5 exponent 1. Okay, so this is 5 exponent 1, and this is also 5 exponent 1 times 2. All right, now that we are having 5 exponent 1 here and 5 exponent 1 here, now we are having, okay, we are having base 5 here and base 5 here. Therefore, we can apply the product rule or the product law of indices. Now, before we apply the product law of indices, let's quote that law, okay? Now, if you're having a exponent m times a exponent m, this will give us a exponent m plus m. That is, if the bases are the same and then they are multiplying, okay, we add the exponents. So this will give us a exponent 2m. All right. So our equation becomes 4 exponent x equals 5 exponent 2 times 2. All right. Now, we know that we can write 4 as 2 exponent 2. Okay, so let's do that. So 4 can be written as 2 exponent 2. All right. Now we are going to apply another law of indices here. Okay. Now this is called the power of a power rule. And we are going to apply that to the left part of the equation. Okay. Now if you're having a exponent m multiplying an exponent c, this is the same as a exponent c multiplying the exponent m. Okay, so you can see we are exchanging the positions of the exponent on top of the base. All right, so we are going to have, okay, we are going to have, and this is the same as a exponent m times c. Okay, now note that multiplication is commutative. Okay, so m times c is the same as c times m. Okay, so our equation becomes 2 exponent 2x equals 5 exponent 2 times 2. All right, now at this stage, we are going to rearrange the components in the equation. Okay, so you're going to have 2 exponent 2x equals 2 times 5 exponent 2. All right. Now 2 here can be written as 2 exponent 1 times, okay, 5 exponent 2. Okay, so we've rewritten, we know that 2 can be written as 2 exponent 1, and that's what we've done, okay? All right. Now, let's divide both sides of the equation by 2 exponent 1 in order to apply the quotient rule. So you're going to have 2 exponent 2x equals 2 exponent 1 times 5 exponent 2. Okay, so divide here by 2 exponent 1, divide here by 2 exponent 1. Okay, so this and this will cancel. So you're having 2 exponent 2x over 2 exponent 1 equals 5 exponent 2. Now, at this stage, we are going to apply the quotient rule. Okay, now before we apply the quotient rule, let's quote the rule. Now we know that a exponent m, or if you're having a exponent m divided by a exponent c, this will give us a exponent m minus c. Okay, now this is what we call the quotient rule. Now let's apply the quotient rule to our equation. So we are going to have 2 exponent 2x minus 1, okay, equals 5 exponent 2. Okay, now at this point, we are having two different bases carrying exponents. Okay, now because the bases are not the same, we cannot apply the equality of exponent property. Okay, since we cannot apply this equality of exponent property, we apply log. Okay, so in situations when we can't apply that rule, we use logarithm. Okay, so we say log 2 exponent 2x minus 1 equals log 5 square, or 5 exponent 2. Now that we have applied log, let's look at the specific rule or the specific law of logarithm that applies in this situation. Okay, so here we are going to introduce a law of logarithm called the logarithm definition. Okay, now if you're having log a exponent n base b, this is the same as n log a base b. Can you see that? All right. Now equation becomes 2x minus 1 log 2 equals 2 log 5. All right. So you're going to have 2x minus 1 log 2 equals 2 log 5. Okay. Now we want to make x the subject of the equation. So we start by moving or eliminating or moving. We want to make x the subject of the equation. So we are going to move anything that is closer to x. Okay. So first we are going to move log 2. Okay. We divide here by log 2 and then here by log 2. Okay. All right. All right. So we have moved log 2 away from x. Okay. Now we have 2 attached to x, and we also have minus 1 attached to x. Okay. So we are going to have 2x minus 1, okay, equals 2 log 5 all over log 2. All right. Now the next thing that we are going to move is minus 1. Okay, so you can see minus 1 is attached to x. So we are going to move minus 1 away from x. Okay, so it's attached to s by subtraction. So it moves to the other part of the equation to become addition. So you're going to have 2x equals 2 log 5 over log 2 plus 1. All right. Now this is the same as 2x equals, okay, so this 2 is multiplying. So this is the same as 2 times log 5 over log 2 plus 1. Okay, now here we are going to introduce another law of logarithm. Okay, this is called the change of base formula. Okay, so if you're having log a over log b, this can be written as log a base b. Okay, this is what we call the change of base formula, okay, in logarithms. So you're going to have 2x equals 2 times log 5 base 2 plus 1. All right, now our equation becomes 2x equals 2 log 5 base 2 plus 1. Now remember that we want to make x the subject of the equation. Okay, now you can see 2 is attached to x and is attached to x by multiplication. Okay, so in order to remove the 2, we divide. Okay, so we divide here by 2, here by 2. Okay, so x equals 2 log 5 base 2 plus 1 all over 2.